In the Marvel Cinematic Universe, Tony Stark's arc reactor is a powerful, compact energy source that powers his Iron Man suit, keeping him alive while also providing seemingly unlimited energy. Though it's portrayed as an engineering marvel, the arc reactor defies many fundamental laws of physics and thermodynamics. Welcome to Part 1, in a series where we go in depth into Tony Stark and his Iron Man armor and tech. In this episode, we are exploring Tony Stark's arc reactor and whether it's physically possible based on our current scientific understanding and the laws of nature.
Wake up, Daddy's home.
1. The miniaturization problem, energy density and power output. One of the most significant issues with the arc reactor is its size-to-power ratio. Tony Stark creates a miniature arc reactor that's small enough to fit in his chest. It generates enough power to operate his life support systems, power his Iron Man suit, and even run his entire company in the later films. To power something as complex as the Iron Man suit with advanced weaponry, flight capabilities, and superhuman strength, the arc reactor would need to output multiple gigawatts of power, far beyond what modern portable energy sources can provide. Even if we imagine an incredibly efficient energy source like fusion, it would still require a large amount of fuel and space, which the small arc reactor doesn't accommodate. The compact size of Stark's arc reactor means it would have to rely on an extraordinarily high energy density. That's the amount of energy it can store relative to its size. Currently, no known material or process can generate the level of energy needed for Iron Man's suit in such a small package. Even cutting-edge batteries, which have energy densities in the range of 250 watt-hours per kilogram, would need to be several times more powerful and still would not come close to the energy needs depicted in the films. 2. Thermodynamics, the conservation of energy problem. The arc reactor violates the first law of thermodynamics, which is the law of energy conservation. This law states that energy cannot be created or destroyed, only transferred or converted from one form to another. The arc reactor, however, seems to create vast amounts of energy out of thin air with no visible input of fuel or resources. In the MCU, it's hinted that the arc reactor operates on clean, unlimited energy, possibly through a process like nuclear fusion, but even nuclear fusion requires input materials such as hydrogen isotopes. Fusion also results in energy loss through radiation and heat. However, Stark's arc reactor doesn't seem to follow this basic requirement of an energy input. If it generates energy on its own without fuel, it would violate the most fundamental law of thermodynamics. Even if it was somehow tapping into zero-point energy, a theoretical form of energy present in the vacuum of space, the arc reactor would still need a method to convert this energy into usable electrical power. The process of harnessing and converting energy still requires an input, which the arc reactor never explains or accounts for.
Dude, you're embarrassing me in front of the wizards.
3. Heat and waste management. The second law of thermodynamics states that every energy conversion process produces waste heat. In a real-world energy generator, whether it's a battery, a nuclear reactor, or a power plant, a large amount of heat is produced as a byproduct of energy conversion. In fusion reactors, for instance, managing the immense heat generated by fusion reactions is one of the biggest challenges. In the films, Stark's arc reactor generates enormous amounts of energy, yet there's no evidence of any significant cooling system or heat management in place. If the arc reactor were real, Stark would need to figure out how to keep the reactor cool without compromising the power output, which would likely make the device much bulkier and less practical.
Power at 400% capacity.
How about that?
4. Material limitations. Another key issue with the arc reactor is the materials required to build such an advanced piece of technology. The arc reactor is shown to contain palladium and later vibranium, but these materials must still follow the laws of physics. Palladium, for instance, is a real element used in catalytic converters and hydrogen purification, but it's toxic in large amounts and certainly isn't known for energy generation. If the arc reactor was subject to real-world material constraints, it would either fail rapidly or require frequent maintenance and repairs, which we don't see Tony Stark performing in the films.
Lab's all set up, boss.
Oh, actually, he's the boss. I just pay for everything and design everything and make everyone look cooler.
5. Fusion and radiation, safety concerns. In reality, having a fusion reactor inside a human body would require extensive shielding to protect the surrounding tissues from radiation damage. Tony Stark shows no signs of radiation sickness or adverse effects from having such a powerful energy source near his heart. The arc reactor's apparent lack of radioactive emissions or protective shielding defies the principles of radiation physics. The absence of any radiation shielding or environmental impact is another indication that the arc reactor violates basic principles of physics.
Whatever.
6. Energy efficiency and perpetual motion. The arc reactor's seemingly infinite energy output also brings up the problem of efficiency. In the real world, no energy system is 100% efficient. Every conversion of energy results in some loss, typically as waste heat. The arc reactor, however, appears to operate with near-perfect efficiency, providing endless energy without any degradation or waste. The arc reactor's ability to continuously output energy without needing a significant fuel source or losing efficiency over time suggests that it's a form of perpetual motion machine, something that is fundamentally impossible in our universe. While Tony Stark's arc reactor is a brilliant plot device that makes for exciting storytelling, it defies numerous scientific principles. The strict laws of thermodynamics and physics prevent such a compact, limitless energy source from existing. Until we make a breakthrough in fusion energy, material science, and energy conversion efficiency, Tony Stark's arc reactor will remain a work of fiction, one that captivates audiences, but cannot exist according to our current understanding of physics and thermodynamics. We hope you enjoyed our breakdown of Tony Stark's arc reactor, and we'll see you next time.